Okay, I told you I would record the practice problems for Newton's laws, and I also told you I would slow down, so let's see how well I do at the slowing down part. Okay, number one, you have three boxes sitting there. You have an A and a B and a C. And you should easily be able to see that for box in diagram A, the net force is going to be 350 newtons to the right. And then you can do net F equals ma and find the acceleration of your box. For B, you should easily see that you have a force to the right and then a force at an angle. The force at an angle can be resolved into the y component and the x component. And then if you make the little xy chart like I taught you a long time ago, you can get the net force because you can do Pythagorean theorem from the x. You'll have that x that's the red one, and I think it's, what, 300 newtons to the right, so it's positive. And no y there. And then the one that I resolved into the aqua components has an angle here of 60. And the sine of 60 is 0.866, so if you take 0.866 and multiply it by 400, you get 300 and something newtons, and that'll be positive. And if you take the cosine of 60, which is a half, and multiply it by 100, you'll get a positive 200 newtons right there. And then you can add up your x's and your y's and do your Pythagorean theorem and get your net force. Hopefully that won't be an issue for you. And then you should see that on box C it looks like you have a tug-of-war going on. You have 80 newtons to the left, and then you have 60 newtons to the right. So it looks like the left force is going to win, and then you can, once you know how big the left force is, then you can do net F equals ma and finish out the problem. Okay, let's move on to 2. Okay, on 2, you're just looking for the weight, and weight is just mass times gravity, so depending on where your object is, you'll have different values for g, so I give you the gravity on Earth and the Moon, so you should easily be able to get the weight. Okay, question 3 says a car of certain mass is moving at 20 meters per second, and you want it to get stopped, so you know the VI is 20 meters per second, and the VF is 0, because you're going to stop it. And you know the distance that it's going to be happening in is 80 meters. So you should be able to use BF squared equals VI squared plus 2AD, solve for A, and then do net F equals MA. And the only force that's going to stop it is the braking force, whoever put the brakes on. And so that's going to be your net force. Not a big deal at all. All right, let's go on to number 4. On number 4, it says that you have a mass hanging from a cord. What is the tension in the cord? So if it's just hanging there, that's the force of gravity, and that's the tension up. There is no acceleration if it's just hanging there. So tension, let's let be positive, force of gravity be negative, so force of tension minus force of gravity is equal to m times a, but a is 0, so that whole thing is going to be 0. So you can find your force of tension. Now it says we want to accelerate it straight upward, so we're going to do the same thing, except this time we will have an acceleration upward. So you're looking for your force of tension again, so it's going to be mass times acceleration plus the force of gravity. And then part C says we want to accelerate it downward. Now what's the current tension in the cord? Force of tension minus force of gravity equals, and this will be a negative ma because remember we want it to go downward, and downward is negative. So then you'll solve for your tension. Force of tension equals negative ma plus force of gravity. Number 5. Number 5 says you have a cord that is capable of holding a 20 kilogram mass at rest. So this is going to be very similar to the fish problem that you did. So you know that the maximum mass that it can hold is 20 kilograms. So the maximum tension, let's call that the force of tension, is in this case going to be equal to the weight, which is mg, because you're just going to hold it still for part A. Okay, then part B says you attach this same cord to a 5 kilogram mass at rest. So how much acceleration can you give to it before the cord would break? So you're going to take that same force of tension, and here's your 5 kilogram mass, gravity, tension, positive, negative, so force of tension minus force of gravity equals MA. You know the maximum tension that this cord can handle because you calculated over here. So you know that value. You know this is just mass times gravity, and you know that mass, and you're looking for that acceleration. And then you'll know whether it's positive or negative. If it's negative, it's going to fall down. If it's positive, it's going to go up. Number 6. 50 kilogram woman stands on a scale inside an elevator that reads the force that the elevator floor pushes upward on the woman. What does the scale read when the elevator is stationary? Well, it's just going to register her normal weight because of the force of the scale minus the force of gravity is equal to MA, and she's not moving, so that whole quantity goes to 0. So the force of the scale minus the force of gravity is 0, and you should be able to solve for the reading on the scale. Now part B works just like the tension one. I want her to accelerate upward, so I'm going to say the force on the scale minus the force of gravity is equal to MA. I'm going to let the scale upward be positive and gravity downward be negative, so no big deal. My acceleration is upward. Part C, the elevator is going to go downward, so I'm going to do the same exact thing, scale reading upward, gravity pulling downward, and if I want her to accelerate downward, then I need to have a negative MA right there. So I should be able to simply solve that problem and find the force on the scale. Oops, sorry, messed up again. Try to not make it look like a G, and then I drew a G. Okay, let's move on to 7. 7 says the driver of a 500 kilogram sports car heading directly for a railroad crossing 250 meters away puts the brakes on. The car is moving at 40 meters per second, and the brakes can apply a force of 1,200 newtons. How fast will the car be going when it reaches the crossing? So I'm looking at VF squared equals VI squared plus 2AD, but I have to find the A. Well, the only force that's going to stop this thing is the net force of the brakes. So I know my net force is given to me as 1,200 newtons. And I'm going to make it negative because it's a stopping or retarding force. Mass is 500 kilograms. So I should easily be able to solve for the acceleration, and I believe you're going to get a negative 2.4 meters per second squared, which you can then put up here as your acceleration. You know the VI was given to you as 40 meters per second. And you know how far away the railroad crossing is. That's given to you. So that should easily allow you to find your VF, the speed he has when he gets there. And then part B says, will the driver escape collision with the freight train that at the instant the car's brakes are applied is blocking the crossing and still requires 8 seconds to clear the crossing. So you need to find the time he takes to get to the crossing. And then compare that to the time it takes the railroad car, to complete the crossing, and you'll know whether he's going to have an accident or not. Okay, we hope he doesn't, but it could be. Number 8. 1,500 kilogram car is traveling with a speed of 15, magnitude and direction of the horizontal force needed to stop it. So it's still going to be very similar to what we just did up there, net F equals MA. The only force acting on it is going to be the brakes, so the net force is what we're looking for. We need the mass, which is given to us, and we've got to find the acceleration, and they give us they expect me to find the acceleration because they give me some distance. Well, VF is going to go to 0. VI is going to be 15 meters per second, and D is going to be 50 meters. So you have enough information to find your acceleration, and then once you know that, you can go back and get your net force. More of the same. Number 9. When a 58-gram tennis ball is served, it accelerates from rest to a speed of 45 meters per second. The impact gives it a constant acceleration over a distance of 44 centimeters. Change that to meters, please. What is the magnitude of the net force? All right. So it's the same thing. VI is 0, just like number 8. VF, we want it to go 45 meters per second. It doesn't look much like a 5, so let's see if we can fix that. And we need the acceleration, and it's going to travel a distance of 0.44 meters. And then we can go back and do net F equals ma once we know our acceleration. More of the same. Okay, number 9 is done. Number 10 is next. During a circus performance, a 72-kilogram human cannonball is shot out of an 18-meter-long cannon. If the human cannonball spins 0.95 seconds in the cannon, find the acceleration, well, find the force. Same thing, net F equals ma. And I believe you have D equals 1/2 AT squared as an option here because he is initially at rest. And you know how long he's in the cannon. And you know how far he has to move through the cannon, so you can solve for the acceleration. And then once you have that, you can go back up and get the net force. More repetition. Number 11. A rock of 45 kilograms accidentally breaks loose from the edge of a cliff and falls straight down. Air resistance is opposing the motion by acting in that direction for 250 newtons. Gravity is pulling down on it. And they want to know the acceleration. So again, net F equals ma. So we have force of gravity down. I'm going to let that be positive, and up will be negative. Minus 250 is equal to m, which is your 45 kilogram mass. And your A is what you're looking for. Don't forget that the force of gravity is just mass times gravity. Okay, I think you're in good shape.